And then he walks over here, and I'm okay with that too. Hey, this is the outside of class examples from 1.2, and we had done in class another parabola, and so this is asking us to find the equation of that parabola right there. And there's two forms of equations for parabola. There's vertex form. I'm going to write that right here, which looks like this. I'm going to go ahead and write y equals a times x minus h squared plus k. And their standard form for a parabola, which is y equals ax squared plus bx plus c. And in this form right here, you have to know the vertex. And the vertex, this vertex form 1, is h comma k. And so I go over here and I say, ooh, I hope I know the vertex, but I don't. I might be able to approximate the vertex, but I don't really know the vertex. And so I'm like, oh, if I don't know the vertex, then what I'm going to do is I'm going to have to use the standard form. And so I'm going to have to use that. And so when I start thinking about this, what this means, that ordered pair, that means that x and y are on the parabola. And what we're going to find, remember that there are infinitely many values for x and y. So here's y right there, and here's x right there that make this true. And we're looking for the a, b, and the c that will make all of the values for x and y true. And so I'm kind of interested in this one. I don't know if you guys are interested in it more than anything else. And the reason I'm interested in it above all else is because it has 0 in there for x. If anything else had a 0 in it, I probably would start with it. So this is saying when x is 0, y is 1. And so when I put that in here, y is 1. When x is 0, I'll put in those other places x is 0. This becomes y equals, so I'm kind of following this form along. I'm going to write it up here, make sure everyone sees that, hey, I am using this formula. So here's a, and then x, what did we say? It was 0 squared. Then b, and then what did we say x was? Well, it was 0 plus c. And you notice how lovely that is, because that point gave us the value of c. c is equal to 1. So now we know c is equal to 1. And we needed to find, in order to find the equation of the parabola, we needed to find a, b, and c. That's what we needed to find. And we used 1 point, and it told us what c was. I just want you guys to, because I don't know that point. I was thinking, ooh, maybe I could use symmetry, but I don't know the vertex there. So this point right here, negative 2, 2, x is negative 2, y is 2. Let's see what it gives us. Remember, c is 1. We can put that in. So here, x is negative 2, y is 2. So right in here, we get 2 times a, and then x was negative 2 squared, plus b, negative 2 plus c. But what am I going to put in for c? I'm going to put in 1. And so this actually has 2 unknowns in it. I'll fix it up, make it look a little bit better. So this is 2 equals negative 2 squared is 4. If you're like, why did you use those parentheses? When you substitute, parentheses are implied. And so since I substituted a number in for that variable, I needed to have the parentheses. So this is negative 2 squared. And why it's important is because negative 2 squared does not equal negative 2 squared. So if you're like, hey, there weren't parentheses to begin with and you put them in, yeah, they're implied when you substitute. And if I didn't put them in, I would be getting a different value here. And so this is minus b plus 1. I'm going to take away 1 from both sides. And I'm going to get 1 equals 4a minus 2b. That has 2 unknowns in it. That equation right there, I'm going to put a box around it so I don't lose it. And I'm going to see if I can get another equation. Okay, so using this ordered pair over here, I can get another equation. So here it's saying x is 1 when y is negative 2.5. So I'm going to erase that off here. And so right here in for y, I'm going to be putting in here negative 2.5 equals ax squared. So what was x? It was 1 squared plus b times 1 plus c, which is 1. And yes, I'm sorry that I got right into that. That happened to me. And so it's going to move that over a tiny bit. Okay, so here this is going to be negative 2.5 equals a plus b plus 1. I'm going to take away 1. So I get negative 3.5 equals a plus b. And that's another equation. And now I have two equations to unknowns. I got pretty lucky that that they had given me this intercept here, because the y-intercept, because if they hadn't given me it, then I wouldn't have been able to use it to find c, and I would have had to solve 3 equations, 3 unknowns. I know that you remember doing that in your math, in your beginning algebra days, and but luckily I'm not going to have to do that. So if I want to solve this, let's say that I want to solve it for b, I'd have to just multiply this equation by 2, and then when I stack them and add those equations together, then I could find the value of a, right? So I'm going to try to eliminate b by multiplying this equation. I'm going to multiply it by 2, and I'm going to stack them. So I'm going to take this first equation here. I'm going to just write it down. 1 equals 4a minus 2b. And then I'm going to multiply here by 2. So negative 3.5 by 2 is negative 7. 2 times a is 2a. And 2 times b is 2b. So this is my first equation, and then multiplied by 2, my second equation. I got them stacked. I'm going to add the equations together. That's the addition method of solving 2 equations, 2 unknowns. So I get negative 6 equals 6a, and the b's cancel out. And so now I can find a. A is negative 1. And then I want to know what b is. I can use either one of my equations. I'll use this one just because it's nice. And so we'll have here, I'm going to use this equation right here, 1 equals, and then 4 times a, which is negative 1, minus 2b. So this is 1 equals negative 4 minus 2b. I'm going to add 4. So I get 5 equals negative 2b. And when the dust clears, I get b is negative 5 over 2. So I'm going to divide by negative 2, right? And it doesn't matter if I put the negative in the top or the bottom. So now I know what a is, what b is, what c is. And so I'm ready to say my equation. And I've pretty much taken up all my board space. I think you guys might have room underneath. I hope you do have room underneath. I don't know if you do or not. But here, I want to put it back because they asked me for the equation. So here it is. Y equals, we found that a was negative 1. So this is negative 1 times x squared, which is negative x squared. We found that b was negative 5 halves x, and that c was 1. So there's my equation that they asked me for. Okay, so we did a lovely job on that. I feel like I should check that one. I just don't remember the answer. So I'm going here, chapter 1. I didn't check that other one. I should have. And this was problem 12. Oh, hot diggity dog. Okay, we'll call it good. It's right, definitely. They said negative 2.5, and I put negative 5 over 2. Yeah, same thing. Great, fabulous. Okay, and let's see here. That's 12, 19, and that's the end of what I got to record this week. And so that's good. Just one more problem. I don't know if it's this eraser that's so bad. There's a better one, huh? It is better, a little bit better with that eraser. But it's pretty bad. Okay, it says the manager, this is problem 19 on 1.2. The manager of a furniture factory finds that it costs $220 to manufacture 100 chairs in one day and $4,800 to produce 300 chairs in a day. The cost as a function of the number of chairs produced, express the cost as a function of the number of chairs produced, assuming that it's linear. So what they're kind of wanting us to do is they're saying the number of chairs produced is our independent variable, and our cost is, is the dependent variable. So they're kind of wanting us, did they give us variables on this? No, they didn't. And so this is going to be number of chairs is going to be like our x value. Number of chairs is going to be like our x. And then our cost is going to be like our y. That's what they're kind of wanting us to do as our ordered pairs. So when we look at this, we have going 2,220, and we made 100. So when they made 100 chairs, that cost them $2,220. So we have this 100, 220, and we also had 300, and 4,800, right? So they said that it was linear. So if it's linear, if we know the slope, then we're in business and we'll be able to find the equation of it. So that's what I want to do next, is find the slope. And so I have my slope formulas memorized. Maybe you do too. I have them memorized with x1 and y1, x2 and y2. So the slope is y2 take away y1 divided by x2 take away x1, which is 4,800 minus 220, and x2 is 300 minus 100. And so now I'm glad that I did get that calculator out earlier. So 4,800 take away 2,200, 2,600 over 200, right? 300 take away 100 is 200. So when I divide that by 200, I get 13. So the slope is 13. And I have the formula memorized, point slope formula memorized as y minus y1 equals the slope times x minus x1. So my y1 is 220, so y minus 2,220. No, 2,200. I don't know, I'm kind of tired. 13, and then x minus x1 is 100. So when I distribute here, I'm going to get 13x minus 1,300. And then I'm going to add the 2,200 onto the other side. And I'm going to get y equals 13x, and then, let's see here, negative 1,300 plus 220, 900, so plus 900. Now they didn't give me variables, like they didn't say to use C for cost, and I used Y for cost, right? And X to be the number of chairs. Let's see here. They wanted me to sketch the graph. Okay, I'll sketch the graph. I'm kind of like, I was laughing because we're going to cross the y-axis here at 900, right? And so my graph is going to look a little silly. I could make 0 chairs, right? So if I'm going to sketch the graph, I might maybe, I know it's linear, 0 chairs I could make. I'm not going to make negative chairs, and that would be 900. Going to cost me $900. I don't know why. If I just have I'm having to pay for the building, and so even though I made no chairs, it cost me $900. And let's say that I make 100 chairs. you probably should know that one should be 220. I keep saying 220, but it's not, it's 2,200. But if you did put in 100 and did the math here, you should get that. And so then I'm just gonna kind of plot this. It's only in the first quadrant. So I'm just gonna kind of go here at 0, I'm up here at 900. So right here is gonna be 900. And then right here is gonna be 1,800, it is a sketch. And then here is gonna be 2,700. And so right here somewhere, it's gonna be 22,200. So right here, and then I'm gonna count over here 100, and then right here. And it should be linear. So that's a line. If I had a ruler, it'd be better. Okay, they asked me, what is the slope of the graph and what does it represent? And so we had already found the slope. The slope was 13. And they want to know, so they asked me to find the equation. I was going to say, if they didn't ask me to find the equation, I could have just plotted the points they had given me and come up with the picture of the line. The slope is 13. If you wanted to write this as a fraction, that was what our slope was, and then put some units on it, it sometimes helps you on what it means. So in the numerator, right, are the y values, the change in y, and the y values were costs, so those are in dollars. And then the denominator is number of chairs. So what this is telling us is every time we increase the number of chairs by 1, it costs us $13. So for one more chair, it costs $13, right? If we decrease the chairs by 1, then it'll be $13 less dollars. But for one more chair, it costs $13. Okay, the other question they're going to ask us here is part C, and asks us, what does the y-intercept represent? So that's 900 right there is the y-intercept. And they're asking us, what does it represent? So the y-intercept is 900, and just so you remember, that's where our x equaled 0. X, remember, was the number of chairs, right? And so the y-intercept being 900, it means that if we make 0 chairs, if we make no chairs, it'll cost 900. So it represents the cost to make 0 chairs is $900. And so anyway, so there's kind of the end of that extra problems. Okay, and cut.